So, second lesson of physics, lesson 2.2, instantaneous velocity and speed. So, you think you're driving down the road, right? And you're like, oh, sometimes going faster, sometimes going slower, but overall I went this speed. That's average velocity, or right? But like if you look at the speedometer, like boom, right then, that's instantaneous velocity. Instantaneous velocity is exactly what it's the velocity at any given instant of time. So it's not like spread out between 2 seconds or 3 or 4 or 5 seconds or even half a second. It's at that exact moment of time. How do we calculate the exact velocity that you're going? So, what is super exciting to me is that we are going to have some calculus today. I did not get this ready. It's all right. You guys don't mind watching me fumble through a little bit, right? Because I'm not redoing my video. Let's go back to yesterday's notes. Okay, now I'm ready. I don't need this. We can calculate calculus in our head, can't we? No, we really can't. Please don't try. So today we are going to calculate some calc you less into the lesson. And it's going to be fun, even if you don't think so. You're going to have to make it fun. Otherwise, you're going to be sad. And who wants to be sad? Okay, given a particle's position at any function of time. Function of time. Okay, that means function of time. Time must be the x. Calculate the instantaneous velocity, for any particular time. So a moment in time. Given a graph of a particle's position versus time times the x, position is the y. Determine the instantaneous velocity, for any particle in their time. Identify the speed as the magnitude of that instantaneous velocity. So it's like, let's say that south side is like in the positive direction and my home is in the negative direction. If you're like, hey, Miss Langeli, how fast do you go home? I wouldn't say like, oh, I go negative 55, right? I would be like, I just go 55 because that's my speed. Okay. A clickable link. Oh my goodness. Mrs. Langeli provides so much fun stuff for you. Look at this really cool
Now, once
clickable
again, we're
link.
going to look at the graph of an
He
object's
sounds really
position over
excited.
time.
So let me just encourage you in this way, okay? If your math teacher needs to maybe watch a few videos to really understand the meat of a lesson, it would not be a bad idea for you to also watch things that she needed to watch to understand. It's going to take a lot of time, but it might pay off in the end. Imagine that. Be a physics master. We have now defined two ways to define how fast something moves. So we definitely have talked about speed. Speed and velocity. Again, might be worth your time to pause the video and watch that because who can get enough math? When we ask the question, how fast is something going? We're talking about a value of the speedometer that you would read. This value is known as the instantaneous velocity. Let's define instantaneous velocity because I know you guys can't wait to write a whole bunch. It is how fast a particle is moving at a given instant. Okay, so like this race car. Okay, I really enjoy being weird in case you're wondering. So instantaneous velocity. Oh, buddy, here's the calculus. It is the limit as the change in time approaches zero. So you're not talking about 2 seconds. You're not talking about 1 second. You're not talking about half a second or a fourth of a second or an eighth of a second or a 16th of a second or a 32nd of a second. You're talking about instantaneous. As the change in time is zero. We get our derivative. Oh, dx dt, Mrs. Langeli, what are you talking about? So that's like, it's the derivative of your position based on, in, what's the word? In respect to time. Up here we have our dependent variable. Is that like so weird, right? And down here we have our independent variable. Oh, so bizarre. All right, this is called a derivative. Derivative. Long story short, a derivative is just a slope. It is the instantaneous slope of any equation at any time. Um, what we need to do in order to find this right now, we need to find 2 points. I'm going to teach a shortcut, but find 2 points that are super close. Okay? And then we'll like get the slope, and then we'll do 2 points that are closer, get the slope, do 2 points that are closer, get the slope, find 2 points that are closer, get the slope, and then we'll see what the slope is converging to. In words, we're looking for time gets smaller and smaller and smaller. That's what we're doing. Time gets smaller and smaller and smaller. Smaller, ooh, and smaller until we're at an instant. Calculus, it is the limit as t approaches 0. So you're like, yeah, I've done calculus. Some of you have. And it gives us the derivative of position with respect to time. Wow, that was just a loaded statement right there. Welcome to calculus. V, which is instantaneous velocity, at any instant is the slope of the position time curve, like the graph example, at the point representing that particular instant. Let's take a look. We know that slopes can be positive. We know that slopes can be negative. And we know that slopes can be 0. And this right here comes from the fact, or maybe due to the fact, or proves the fact that velocity is a vector. If you take a look at these, what I want you to focus is, okay, this is going to be hard for me to trace, so I'm going to highlight it. This represents the position of a particle. So the particle looks like it's going up, 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 slowly. Look at it. So if I was interested at an average, so let's say I wanted the instant velocity here. I would need to find the slope of the line, my green line, at that particular point. So what we're going to have to do is pick different points and kind of converge to that one point and compare the slopes. And you can see like, okay, I guess I could just pick a random point here and find the slope, a random point here, find the slope, a random point here, find the slope. And you can see like they will all start to converge to a certain number. You're going to really love this, okay? You have no other choice. And we'll get to that in this little cheetah problem. Speed is defined as the magnitude of velocity. Miss Shirey is dancing at my door. Which is simply the absolute value of velocity. I should be grading late work right now, but physics is just way more fun. So let's say that we have example 1. What is the speed that's associated with a velocity of 5 meters per second and a velocity of negative 5 meters per second? Well, the speed is the absolute value, so it'd be 5 meters per second either way. That was just trying to explain that sentence up there. Example 2. Now this one's where you're going to have to put your big girl, big boy pants on because this is a big one. A cheetah, you got to like picture it. A cheetah is crouched 20 meters to the east of an observer. At the beginning of the problem, at the beginning of time, t equals 0, the cheetah begins to run due east towards an antelope that is 50 meters to the east of the observer. During the first 2 seconds of the attack, that says attach, not attack. I totally blame Mr. Bernie for that. Like I shouldn't read it through anyway. Okay, during the first 2 seconds of the attack, the cheetah's coordinate x varies with time according to this equation: 20 meters plus 5 meters per second squared times t squared. In other words, maybe it'd be easier for you to like, okay, position is 20 plus 5t squared. And just know that like the units work themselves out. Find the cheetah's displacement between 1 second and 2 seconds. We can do that. Find the instantaneous velocity at 1 second by taking itty bitty time frames. So start at 0.1 seconds and 0.01 seconds and 0.01 seconds and derive an expression for the cheetah's instantaneous velocity at a function of time. Let's just start easy. Ready? Part A. We're going to find the displacement between t equals 1 and t equals 2. So between 1 and 2 seconds. We can do this. So they gave us a pretty little equation. Boop, 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 boop. I feel like using a different color that's as close to the first color as possible. So our equation was 20 plus 5t squared. Okay, so let's talk about at t equals 1. Everybody ready? X is going to be 20 plus 5 times 1 squared, which is 20, plus 5 overall, which is 25. And that's his displacement, so 25 meters. Now t equals 2. X, this is his new position at t equals 2. His new position is 20 plus 5 times 2 squared, which is 20 plus 4 times 5, so it's 20 plus 20, right, which is 40 meters. So the word displacement, we have learned displacement is your final position minus your original position. So I'll do 40 minus 25. In other words, you're like, how far did he run between those two times? 40 minus 25 is 15 meters positive as a displacement. So he went 15 meters in the positive direction. Now for part B. Part A, you're like, okay, I can handle part A. I got that. Part B. Um, where is my part B? It's very messy on my paper. That's okay. There is no part B. Part B is, haha, joke's on you. I didn't check it very easily, did I? So mine says part C. You know what I'm going to do? I'm going to change yours. This should be a B, not a C. Sorry, guys, I'm finding some errors as I go along. Let's just make that C. I don't know what my problem was. I'm sorry, guys. Okay, so part B. Let's go ahead and I'll just fix your notes. Yours won't say attach and it won't say part C. Okay. What we need to do is find the instantaneous velocity. Instantaneous velocity is the slope of the line as you get closer and closer and closer and closer to time equals 0. So here's what we're going to do. They want us to do it at 1 second. So ready? I want you to write this down. Instantaneous velocity at 1 second. So right now, I need to get 2 points because we know that we need 2 points to find a velocity. So here's what I'm going to do. I am going to let my time equal 1. I'm going to let my second time, because I'm just trying to look at a glimpse. Like if you could picture having a recording of this and pausing it at 1 second, fast forwarding it to, how far do they want me to go here? They want me to fast forward 0.1 second from there. So 1.1, now I need to find the x's associated with those. So at this particular one, x is going to equal 20 plus 5 times 1 squared. It's going to equal 25. Now what we're going to do is we're going to fast forward just a little bit in our video and go to 1.1 second. And you're probably going to want your calculator here. I would suggest pausing the video, just making sure you know how to plug things in your calculator, okay? When you plug in 1.1, you get 2605. Okay, so in this delta time of 0.1 second, I can say that the velocity in that particular is the change in my displacement over the change in my time, which would be 26.05 minus 25 over a change of time is just 0.1. Please type that in your calculator. Please make sure you can get the same answer I get, 10.05 meters per second. So that was between 1 second and 1.1 second. Now what I need to do is follow the rest of the problem. They say, okay, let's fast forward our video even smaller and compare it. So let's just fast forward our video 0.01 seconds. So, okay, here I go. So now I'm going to need to let t equals 1 and t, the second t, I guess I can call it t1 and t2. I need to let that equal 1.01. So I'm really, really just looking at almost a moment at time now, in time, not at time. So x equals 20 plus 5 times 1. We already know that's 25. We've done that. Now we haven't done this one. 20 plus 5 times 1.01. Remember, we're like barely fast forwarding our video. Please take the time to pause the video, put that in your calculator. You are going to end up with 25.1005. 25.1005 meters. Okay, so we can see like, ooh, that's getting like, we're definitely really, really fast forwarding this. It's an itty bitty bit because he's barely moving. So our velocity will be delta x over delta t. So delta x is 25.1005 minus 25. And delta t, remember, we're only going to look at that much of a video. So that's going to be 0.1005 over 0.01. And that is going to equal, please type that in your calculator, make sure you know it's 10.05 meters per second. So we can really see, okay, so the velocity is 10.5 for a difference of 0.1, 10.05 for a difference of 0.01. So we're getting closer and closer and closer. Let me see how much room I have here. I'm going to move. I'd like to keep this here, but I'm going to zoom in. I just really wanted to kind of keep this all in one spot. Okay, here I go. Now I'm going to let t equal 1. Now let's see what else they want me to do. They really wanted me to make it a super small. Can you imagine if you only fast forwarded a video that much? So that means I need to go that much away from 1 second. So that would be T1, this would be T2, 1.001 second, super small increment in my video. Let's plug that in. So x, my position would be 20 plus 5t squared, which we have done like 4 times now, 25 there. X, this position, position 1, position 2, is 20 plus 5 times 1.001 squared. Please pause the video, plug that in your calculator, make sure that you can get 25.010005. 25.010005 meters. So we can really see this is making sense, right? Because like the shorter the time, the farther he hasn't traveled as much. So we're going to do our delta x for velocity. Oops, sorry. Over our delta t. So we're going to do a difference. I hope you guys are okay if I just subtract those. I would get 0.010005 over the difference in time is 0.001. Ooh, type that in your calculator and you're going to get 10.0005 meters per second. Now, if I really was a jerk, I could make you do t equals 1 and t equals 1.0000001 and see what happens. But this should what we've done is probably enough for you to be able to say that they are converging. Oh, good math word. They are converging this one and this one. These are converging to be about 10-ish, right? So what you're going to be able to see is that we can, let's see what the directions say. Find it, okay. We can probably see the instantaneous, oh, that's messy. We can probably go ahead and say that the instantaneous velocity at 1 second is going to be 10 meters per second. Because you're going to notice as your time gets shorter and shorter and shorter and shorter and shorter and shorter and shorter, in between, your velocity, which is simply the slope between any 2 points, infinitely small, is converging to a value of 10. So let's take a look at what should be part C. I know I have part D there, but let's take a look at what should be part C. That's messy. Derive an expression as a function for the velocity as a function of time. Now, guys, you have never done calculus before, so this is going to be a little wonky to you, but I hope you like it because I think you're really going to like how much easier it is than what we just did. Okay, so part C. So we have that the position, right, was x equals 20 plus 5t squared with a whole bunch I know of units. Now, I would like to tell you that the velocity is the derivative of that. Now, what you've never done probably, unless you've watched a video on how to do velocity or derivatives, you've probably never taken a derivative of something before. So here's what we're going to do. We're going to write velocity equals, for derivatives, if it does not have a variable, it goes away. So the 20 is gone. So see this 20? It's gone. I can explain that mathematically later, but long story short, if it doesn't have a variable, it goes away. So the 20 goes away, and we had 5t squared, right? Here's how we change it. Here's how we find the derivative. We take this exponent and multiply it to that number. So it's really plus 10. And then our exponent was a 2, but we have to back off 1. So that really makes my velocity 10t to the first power. Simply put, velocity is 10t. And this is instantaneous velocity. So when I asked you, and I'm pretty sure it did, find the instantaneous velocity at 1 and at 2, watch this. Instantaneous velocity at t equals 1 second would be velocity equals 10 times 1, which is 10 meters per second. And if you look, isn't that what we did? Now the problem also asks for the instantaneous velocity at 2 seconds, I believe. So I'm not going to sit here and make you do all of that. Oh, fast forward it a little bit, fast forward it a little bit, find the slope, find the slope. I'm just going to let you use your new equation, which is v equals 10 times t. Take away the t, put in a 2, so you can assume, or not even assume, you can know that the instantaneous velocity at 2 seconds is 20 meters per second. You don't know, but you just had a huge calc lesson there. All right. I'm going to pause the video, see where we're at, and then come back if I still have more time.